Now let's talk about the multiplication rule. By the definition, probability of event A and event B means event A happens and event B happens. So here we have a new notation. Probability B given A. So here, this means A is the condition. A is the condition. A has already occurred. So this is the conditional probability. Let's talk about the intuitive rule first. We can use multiply the probability of event A by multiply event A by the event B, probability of event B. But you should know this probability of event B is not the regular one. By assuming event A has already happened, which means this event B has a condition, and the probability of this event B is a conditional probability. So there's no big difference between the intuitive rule and the formal rule. Let's check. Multiply the probability of event A times the probability event B, but this B with the condition by given A, which means with the condition A has already happened. So there's no big difference between intuitive rule and the formal rule. Let's check the independence. Why independence is very important when we talk about multiplication rule. First, let's check the definition. A and B are independent if occurrence of one does not affect the probability of occurrence of the other, which means A happens or not will not change B happens or not, or A happens or not will not affect the probability of B. Then we will say these two events are independent. Okay? But if A happens will change the probability of B happens, then we will say A and B are not independent. They are dependent. Let's check an example. First, we just get some information from our previous table. We know positive test result is 45 and the negative test result is 5. And we focus on 50 uses drugs. So 50 people actually uses drugs, but only 45 got the positive result. 5 got the negative result. So 45 use drugs. But 45 positive, 5 negative. Let's check the question. If 2 of 50 subjects randomly select, here, with replacement, which means first I will pick a subject. After that, this subject can go back to the pool. So there are still 50 subjects in the pool. Okay, then we select the second subject. This means with replacement. And we want to find the probability. First, positive. Second, negative. Here we have this keyword and, which means we should use the multiplication rule, right? Event A is positive result. Event B is negative result. A and B. So for the first question, we know it's with replacement, so we can get the probability A first. Positive test result. So we know among this 50 result, 45 are positive result. So among 50 people uses drugs, only 45 got positive result. So the probability of positive result is 45 over 50. So this is event A. This is the event B, negative result. So 5 out of 50 people got negative result. So this is event B. Let's check the probability here. The first positive and the second negative. Because we already know by the formula A and B. We should use this one. Probability of A times the probability of B, but this B has a condition. If we check A and B, we will realize they are independent. Why we will say it's independent? Because the selection is with replacement, which means event A happens or not will not change the probability of B happens or not. So probability B given A is just same as the regular probability, because A happens or not will not affect the probability of B. So with condition or without condition, they're just the same thing. So we can simplify the multiplication formula into probability A times probability B, but we should have this one. Only if A and B are independent to each other. So for this case, the selection with replacement. So for the first one, the probability is PA. For the second one, it will not be affected by the event A. It's 5 over 50. We will get this. Remember, only if A and B are independent to each other, then we can simplify our multiplication formula to PA times PB. Because here, the PB and PB given A, they are just the same thing, because PB will not be changed with condition or without condition. But without a replacement is another story. You will find the first positive result is selected if the subject do not go back to the pool. So that's the meaning of without replacement. It will not go back to the pool. Then for the second selection, the total number has changed. For the second selection, it's no longer the 5 over 50, because we only have 49 in our pool. So the event A happens affect the probability of second selection, event B. So this kind of things, A and B are not independent. We will say this one is PA and this one is P. given A, you will find the different answer from part A. Because this time, without replacement, two selections are dependent. Then the second probability B is a conditional probability. So when we talk about statistics, sampling method is very important, right? Sampling method is important. And we can see if the sampling with replacement, then all of the selections are independent. So with replacement, independent selection. But if without replacement, the selection will be dependent to each other. Of course, we prefer the independent case, right? Because if all of the selections are independent, then we can simplify our multiplication formula. We do not need to use the conditional probability. But if they are dependent to each other, each time we should use the conditional probability for the second event, for the third event, and so on. Of course, we prefer the sampling method with replacement. But we also have this rule to help us. This is called 5% guideline, which means if we have a large population and our sample is very small, so we have this rule, no more than 5% of the population. So if we have 100 as our population size, 100 subjective in our population, but we only pick 5 or 4 as our sample, then we can treat this kind of situation as independent. We can treat the selection as independent even though they are actually dependent. So even though they are actually without a replacement, we can treat them as with replacement. So make sure you know big population, small sample, then we treat all the selection as independent, which means we can simplify our multiplication formula. No need to use the conditional probability. Let's check this example. First, we check here. We have the selection without replacement. So basically, without replacement placement means the selections are dependent to each other. So which means for dependent selections, we should use conditional probability, but we have the 5% rule. So here, we know the total number of adults, and we also know 10% uses drugs. We want to find the probability 3 selected adults all use drugs. That means we first select one uses drugs, and the second one uses drugs, and the third one uses drugs. So here, what is the size of our sample? It's just 3. We only need to pick 3 adults. So here we pick 3 without replacement. But if we use this 5% guideline, we will realize the sample size is very small, just 3, and the population size is very big. So we can treat the selection without replacement just as with replacement. So we can treat all of the events are independent. So the case will be first uses drugs, and the second uses drugs, and the third use drugs. We already know 10% of the people will use drugs, so we use the probability 10%. Right? How can we get this? 0.1? Because we have this 10% of the adults uses drugs, so that's the probability of select an adult who uses drugs. 10% will use drugs. So first 0.1 times second 0.1 times 0.1. So we will get this answer. We treat all the selections as independent, even though they are actually not independent because the selections are without replacement. But based on the 5% rule, we can treat them as independent. So that's the interpretation. Okay, let's try to talk about redundancy. It's just an important application of the multiplication rule. Redundancy, let's check. Why we should have redundancy? Because we can increase the reliability of lots of systems. Let's check the example. So this Airbus 310 has 3 identical hydraulic systems, which means if any one hydraulic system fails, if one of the system fails, another systems will do the same thing, right? So first we have the probability of the system fails is 0.002. Let's check part A. If this airplane only have one hydraulic system, what is the probability? The aircraft would work for a flight. But the second part B, we will talk about if we have the redundancy. This time we have 3 independent hydraulic systems. So what is the probability? What is the probability? It will work for a flight. So first part, if we only have one system, so we can easily to get the probability of system does not fail, because we already know the probability of system fail. So they are complements. So 1 minus event failure, we can get probability of event does not fail. So this is the probability of one system do not fail. 0.998. You think it's high, right? But let's check the second one. If we have 3 independent systems, then the probability of all 3 system failure is the first one fails, and the second one fails, and the third system fails. So we should use the multiplication rule. And we also know these three systems are independent to each other. So we just use the regular probability, right? So for a single system, the probability of failing is 0.002. So the first fail times the second fail times the third fail, we will get an extremely small number. So if means all, this means all of three fails. Then the complement of all of three fail, that will be at least one works. So it's just the complement. 1 minus such small number, we will get this as our probability. Not all of three system fails, which means at least one will work, right? So we will compare to the previous result. We can say this one is higher than the previous one. We increase the safety. We increase the safety. This one 0.998 is high, but it's not enough high compared to the second result. So that's why we should use redundancy to increase our safety. Okay? So this is the reason why we should use redundancy. So that's the summary. So for addition rule, you should check the keyword or. Okay? But the most important part, no double counting. And for this one, you should check the keyword multiplication rule. And we should make sure you check the second probability B is have the condition of A. But if they are independent to each other, which means probability B given A is just the probability P, only if A, B are independent. Okay?